Welcome back, my students. Dr. Ove here. In this video, we are going to study the actions of sympathetic and parasympathetic nervous systems on cardiac action potentials. We studied this question in the previous video. That was the part first of the lecture, and this is going to be the part second of this question. Is that clear? This is from Cardiac Action Potentials, chapter 31. No need to write anything. My handwritten notes are in the description of the lecture. So we are studying the effect of sympathetic nervous system and the effect of parasympathetic nervous system on heart. Is that clear? But what is the sympathetic and parasympathetic nervous system? In our body, there is a presence of autonomic nervous system. This autonomic nervous system, it originates from brain and spinal cord. So this autonomic nervous system originates from brain and originates from spinal cord. Is that clear? And this autonomic nervous system, it controls involuntary functions. Is that clear? This autonomic nervous system is of two types. That is the sympathetic nervous system and parasympathetic nervous system. Sympathetic nervous system is that part of autonomic nervous system which originate from the thoracic and the lumbar portion of the spinal cord. So the nerves originating from the thoracic and the lumbar portion of the spinal cord constitute sympathetic nervous system. So sympathetic nervous system constitute thoraco-lumbar outflow, whereas the nerves that originate from the cranial portion and the sacral portion of the spinal cord, these nerves constitute parasympathetic nervous system. So parasympathetic nervous system constitutes cranio-sacral outflow. Now we will study the effect of sympathetic and parasympathetic nervous system on the heart. Is that clear? We will study 3 effects by sympathetic nervous system and 1 effect by parasympathetic nervous system. First effect by sympathetic nervous system. Sympathetic nervous system, when we stimulate it, it releases a hormone called norepinephrine. This norepinephrine is released at sympathetic nerve endings. Sympathetic nerves are the nerves of sympathetic nervous system. At its endings, norepinephrine is released. This norepinephrine goes on and stimulates beta-1 adrenergic receptors. And when we stimulate beta-1 adrenergic receptors, it increases heart rate. So if we stimulate a sympathetic nervous system, heart rate will increase. And if we find a way by which we can block these receptors, we can decrease heart rate. If we block these receptors, is that clear? So this is the first effect by sympathetic nervous system. Effect number 2. Let's suppose this is a cardiac muscle. For a cardiac muscle to contract, it needs calcium. Clear? So if we stimulate sympathetic nervous system, what does this sympathetic nervous system do? It increases permeability to calcium. That means more and more calcium comes inside of the cell. When more and more calcium comes inside of the cardiac muscle, there is more calcium for contraction. That means contractile strength increases. That means when heart contracts, it contracts with a stronger force. It contracts with a stronger strength because there is more calcium available. So these are the 2 effects of sympathetic nervous system, 1 and here. Now moving on to the 3rd effect. Let us suppose impulses. We know that impulses are generated in SA node in the atrium. Then the impulses go to AV node. Then the impulses go to AV bundle. And then the impulses go to ventricles. So when SA node impulses are generated, they contract the atrium, and then the impulses travel and they contract the ventricles. Is that clear? The time taken by the impulse to go from SA node to the ventricles is known as conduction time. Now, when we stimulate sympathetic nervous system, it decreases conduction time. That means the impulses which are generated in SA node, they travel quickly towards ventricle in less time. So ventricles contract quickly. Whereas if we stimulate parasympathetic nervous system, the impulses go from SA node, but they travel like an old man and reach the ventricles. And ventricles do contract, but they contract after some delay. So when we stimulate parasympathetic nervous system, it increases conduction time. Is that clear? So this is the 3rd effect from sympathetic nervous system and the first effect from parasympathetic nervous system. Now I will explain you this phenomena, how sympathetic nervous system decreases conduction time and how parasympathetic nervous system increases conduction time. Is that clear? Let me explain you this. I will explain you this by taking into consideration an SA nodal action potential. So let us suppose this is an SA node. Clear? Initially the inside potential is minus 60 millivolt, like we have been talking. There is an entry of sodium through sodium Finney channels, and there is entry of calcium through calcium T type of channels. When this sodium and calcium enters, it takes the potential from minus 60 to minus 40 millivolt. Because these are positive ions, they neutralize this negative and take it to minus 40. And I will show you this statement graphically. On x-axis we have time, is that clear? And on y-axis we have millivolts. Initially the potential was minus 60 millivolt. Due to the entry of sodium and calcium, due to the entry of sodium through sodium funny channels, and due to the entry of calcium to calcium T type of channels, potential went from minus 60 to minus 40. Is that clear? This is called pre-potential phase. This is the pre-potential phase of action potential. Now what happens? Now when the inside potential is minus 40, there is entry of another type of channels. Those are calcium L type of channels. Now the positive charge is coming inside. They take the potential from minus 40 to plus 10 millivolt. Is that clear? Now when minus 40 is reached, there is entry of calcium through calcium L type of channels, and they take the potential to plus 10 millivolt. And this phase is called the depolarization phase. Is that clear? Now moving forward, after that what happens? When this plus 10 millivolt potential is reached, there is efflux of potassium. Positive charge leaves the cell and these channels close. So when positive charge leaves the cell, this plus 10 millivolt is taken back to minus 60 millivolt. So this plus 10 is taken back to minus 60 millivolt by the efflux of potassium. And this is called a repolarization phase. So this is an action potential of an SA node. This one action potential generates one impulse. Then what happens? Then again there is another pre-potential phase from here to here because of the entry of sodium and because of the entry of calcium, and then there is depolarization and repolarization. Clear? So this is the another action potential. That means another impulse. So in this way action potentials are generated, and these action potentials in turn generate impulses which travel from SA node to ventricles. Is that clear? Now we will study the effect of parasympathetic nervous system. Parasympathetic nervous system. When we stimulate parasympathetic nervous system, it releases an hormone that's called acetylcholine. What does this acetylcholine do? It increases potassium efflux. And what happens with this potassium efflux? There is hyperpolarization. What is this? What is the phenomena of this hyperpolarization? Let me show you. So what happens in repolarization phase? There is leaving of potassium. So positive charge leaves the cell and it takes the potential from plus 10 millivolt to minus 60 millivolt. Is that clear? But at minus 60 millivolt, these potassium channels close. But when we stimulate parasympathetic nervous system, these potassium efflux is still continued and they take the potential below from minus 60 maybe to minus 70, then to minus 80. And this phenomena is called hyperpolarization. Now for the next impulse to begin, usually the impulse begins from minus 60 millivolt to minus 40 millivolt. That was the pre-potential phase. Now for the next pre-potential, it doesn't go from minus 60 to minus 40 millivolt. It has to go from minus 80 to minus 40 millivolt. That means for the next action potential to begin, that means for next impulse to begin, it will take more time. So due to this continued potassium efflux, due to this hyperpolarization, there is conduction delay. Why there is conduction delay? Because new action potential, new impulse will be generated, but it will take more time because now the impulse has to go from minus 80 millivolt to minus 40 millivolt. It will require more entry of sodium and more entry of calcium. It will require more time, so there will be conduction delay. So is that clear? That's why I studied parasympathetic nervous system increases conduction time, as when the impulse will be first impulse is generated, but the next impulse is not generated. It is taking time to generate the next impulse. So when the next impulse is not generated, so it will not go to ventricles, so the ventricles will not contract, so conduction time will increase because the new action potentials, the new impulses are not generated because of this hyperpolarization state. Is that clear? Now let me tell you a point. Let's suppose it was a moderate hyperpolarization. If it was moderate hyperpolarization, let's suppose it was from minus 60, it went to minus 70. Clear? Now the new impulse has to go from minus 70 to minus 40. Although there will be conduction delay, but the new impulse will be generated. But if it was very much hyperpolarization, if it was very large hyperpolarization, what will happen is that there will be conduction block. Why there will be conduction block? Because Now the membrane is very much hyperpolarized. It is not hyperpolarized to -70, it is not -80, it is -100 or -110. That means the new potential has to go from -100 millivolt to -40 millivolt. You normally pre-potential goes from -60 to -40 millivolt, but this in this very large hyperpolarization, now the impulse has to go from -100 millivolt to -40 millivolt, and it will not be possible by these sodium and calcium channels to take this -100 millivolt to -40 millivolt for the generation of the new action potential or new impulse. So in very large hyperpolarization, there will be conduction block. These action potentials are seen in AV node as well as in SE node. That means in AV node, if there is large hyperpolarization, now the new impulse will not be generated. So the new impulse will not go to ventricles. There will be conduction block. Ventricle will not contract. The person will die. Is that clear? So parasympathetic nervous system increases conduction time. How they increase conduction time? By release of acetylcholine. And what does this acetylcholine do? It increases potassium efflux. And when potassium efflux increases, it takes the potential to hyperpolarization state. And from hyperpolarization state, it is very difficult to come back to the pre-potential phase to -40 millivolt. Is that clear? Now moving on to the another thing. So this was the concept of how parasympathetic nervous system increases conduction time. Now we have the concept of how sympathetic nervous system decreases conduction time. Let's look at. When we stimulate sympathetic nervous system, it increases entry of sodium and it increases entry of calcium. When the sodium and calcium increases, look at here. When sodium and calcium increases, the slope of prepotential phase increases. The slope of prepotential phase increases. What does that mean? Initially, on x-axis we have time. It took from here to reach from -60 to -40 millivolt. Now, this sodium and calcium is coming more inside. They are coming very fast. So they take this potential from -60 to -40 very quickly. Let us suppose initially it took 0.2 seconds to reach from -60 to -40. Now it takes only 0.1 second to reach from -60 to -40. So slope of prepotential increases. Now when slope of prepotential increases, new action potential will be like this. New action potential will be like this. Now look at this action potential. The initial duration of action potential was from here, because on x-axis we have time, was from here till here. This was the initial duration. Now the new duration of action potential is from here till here. That means new action potential is quicker. Is new action potential is the duration of new action potential is less. Is that clear? Initial action potential was from here to here. New action potential is from here to here. So on x-axis we have time. So this new action potential takes less time. New action potential takes less time. Let us suppose normal duration was 0.6 seconds. Now new duration is 0.4 seconds. That means if initial duration was 0.6 seconds, now due to the sympathetic nerve stimulation, there is only new action potential duration is 0.4 seconds. As it decreased the duration of less duration, it decreased the duration of action potential. What decreased the duration of action potential? Sympathetic nervous system. So in 1 minute, less action potential. In 1 minute, more action potential will be generated. More action potentials will be generated. This was the normal duration. This was due to the stimulation of the sympathetic nervous system. So in 1 minute, more action potential will be generated, because it takes only 0.4 seconds to generate an action potential. So more action potential will be generated in 1 minute. Is that clear? So when this SA node, it took 0.6 seconds normally to generate an action potential. Now it is taking only 0.4 seconds to generate an action potential. So new action potential will be generated at the interval of 0.4 seconds, then 0.4 seconds, then 0.4 seconds. So SA node makes new action potentials quicker. So these new action potentials travel very quicker to ventricles. That means conduction time decreases. As new action potentials are generated quickly, they quickly travel to ventricles and contract the ventricles. So sympathetic nervous system, they decreases conduction time. How do they decrease conduction time? By increasing the entry of sodium and calcium, by increasing the slope of prepotential, or by decreasing the duration of action potential. Is that clear? So this was our concept today. Thank you very much. Dr. Ugwe here. I have made notes of this video. Go check these notes in my Telegram channel. Thank you very much. Do subscribe my channel. It gives me motivation to make more videos. It will be helpful for you. It will be very, very helpful for you, not only to pass exams but to become a good doctor. Thank you very much. Your Ugve here. Class dismissed.